So we'll start back with this problem again. So if we multiply the top equation by -2, that's going to give us a brand new equation. That's going to give us, because if I multiply, I have to multiply everything, both sides, by the -2. That's going to get me -10x, -12y, and -4 equals -4. And then my bottom equation I don't have to worry about at all. It's already ready to go. Ooh, and something interesting is going to happen on this problem. So when I go to eliminate, or I add my equations together, -10x, positive 10x, gone, that's 0. -12y, positive 12y, gone, that's 0. And so what we got on the left side is 0. -4 plus 4, that is 0. Well, remember, an intersection point has an x and a y. I don't have an x and a y. I have 0 equals 0. Is that true or false? That's true. What this means is we actually have infinitely many solutions, because these two equations excuse me, are actually the same equation. It's like if you have 1/2 and 2/4. They mean the same thing, written two different ways. Those two, if you were to put them both into y equals form, would be the exact same. These are the exact same line. So what that means is if we graphed both of them, which sounds kind of weird, but if we graphed one and then we go to graph the other, they have every single point in common. Infinitely many solutions. Now, what I want to point out with this problem as well is, what if on the left side all of our variables disappeared and we got 0? But what if it wasn't 0 on the other side? What if it was 0 equals 5?
False.
It's a false statement, which means we have no solution. In other words, they're going to be parallel lines. So if you put them both in slope-intercept form, they'd have the same slope, they'd have different intercepts, so it would be no solution. Most of the ones you're going to do, you're going to get a solution. It's just if all of your variables disappear and you're left with a true statement, it's infinite. If all of your variables disappear and it's a false statement, it's no solution. So that one we didn't have to do too much work on. We just had to understand what happens algebraically and kind of tying it to what happens graphically makes it make more sense. All right, number 4, function notation. So what this says is, okay,